Hi guys, this is 10.5. Sorry, I lost my train of thought for a second. 10.5 part 3. We're going to talk about graphing in polar form. So whenever we're graphing, the first thing we want to do is we want to figure out what E is because we want to know what shape we're trying to graph. So we don't have to find all the points, right? Yeah. So if we're going to figure out what E is, in this case, we're going to be multiplying everything by 1/3. We get that E is 1, so this is a parabola. Then we're going to figure out our quadrantal angles. So we're going to be plugging in for theta, 0, pi over 2, pi, 3 pi over 2. Because we want those quadrantal angles. So the reason that we want those specifically is that our vertex, wherever that ends up being, our vertex is going to be vertex or vertices, if it's not a parabola, right, is going to be on one of those quadrantal angles. Right? It's going to be one of those quadrantal angles. So this is going to give us the value of our vertex. We also want to know which way this is facing before we start trying to graph it. With a parabola, it's pretty obvious because pi is undefined, so it must be facing open to that direction, because that's clearly where it would be undefined. So that's the only option here, but on the other ones, it's not going to be necessarily that easy. So a way to think about how this is going to open, right, is that directrix is here, is at 5/3. So it's positive, which means it's to the right of the origin, which means that our parabola has to open up to the left. And we knew it was positive because of this positive here. All right. So getting those points, we can get an idea of our parabola, and then we can find things like the directrix. Well, we already were able to find the directrix, and the focus is at the origin. But if this were an ellipse or something, then knowing my vertices would be able to help me find my other focus and things like that. So let's look at a hyperbola. So if I'm graphing a hyperbola, again, I'm gonna take the equation. I'm gonna figure out what E is. E is 3/2, which is more than 1. It's cosine, so it's not cosine, it's sine. Why does this say cosine? That must be a typo. This is sine, so I don't know what happened here. But this is sine, so it's going to be opening up and down. And it's negative. It's negative, so that that sort of directrix thing is at negative 8/3, right? Because it's negative. Isn't halfway between the two, but it is between them. So it's going to be the upper focus that is the one at the origin, because that directrix is below the origin because of the minus. And also, we're going to plug in those points, so that's going to give us that too. So if we plug in those 4 points, same 4 points, right? We're going to get that at pi over 2, we're getting negative 8. So at pi over 2, we're going all the way down here to negative 8. So that's one of our vertices. And then at 3 pi over 2, we're getting 1.6. So 3 pi over 2, we're getting 1.6. So these are our two vertices. If we know that it's going to open up and down, and that one of the foci is at the vertex, then the points at pi over 2 and 3 pi over 2 have to be our vertices. And then we would be able to find the other we'd be able to find the other vertex because it's going to be the same distance from this vertex to the focus. We can the other focus, not the other vertex. We can find the other focus because these two, remember the focus is at the origin. So if this vertex is at 1.6, then the other focus must be 1.6 away from this vertex. So we can find the other focus that way. Yeah. So let's look at the same thing in an ellipse. Again, this is negative and it's cosine. I don't know why this keeps switching. That is so weird. It's cosine, so it's going to be longer in the x direction. It's going to be longer in the x direction, which means that our 0 and our pi are going to be our vertices, right? 0 and pi are going to be our vertices because, again, one of the foci is at the origin. Because one of the foci is at the origin, then the x-axis is our major axis, which means that 0 and pi have to give us, the r values for 0 and pi have to give us our vertices. So again, we have our vertices. We know that there's a focus here at the origin, so the distance between these two, so that 1.1 is going to be the same distance to this focus. So this focus is going to be 1.1 away from this vertex. So this is 10. You're going to go in 1.1, so you're going to be at 8.9 is going to be where our other focus is. So using these 4 points, we can always find the vertices, and we can use that to find the other things that we're looking for. We don't need to find the directrix, but knowing that the directrix is negative tells us that the ellipse is going to be going off to the right. So if the directrix had been positive, then this ellipse would have been going off to the left. So that's what knowing the sign of the directrix will tell you, which is also what this sign does. It tells you whether you're going off to the right. So you go off to the right if it's negative, off to the left if it's positive. And that's going to be true regardless. But again, you don't need to know that because your vertices are going to be given to you, are always going to be in these 4 points. Obviously, not all 4 points are vertices, but the vertices are going to be somewhere in these 4 points. So if you plot these 4 points, you're going to have your vertices. So hopefully that helps. Yeah. Hopefully that helps. I think that's the end of 10.5. And let me know if you have any questions, and I'll see you guys later.